Flipped classroom video for Maths AS Unit 1, Linear Inequalities. We're first going to have a look at notation, because it's pretty useful to get all this right. And we're looking at inequalities versus equations. So you will have met inequalities before. Essentially they're different from equations in that they give ranges of values that are possible solutions in a given situation rather than specific values. And in order to make clear what these values are, it's useful to know about intervals. First, we'll think about the basic symbols you already know about. So we've got less than and less than or equal to, and we've got greater than or more than and greater than or equal to. But if we want to define sets of numbers, there are different ways we can do it as well. If we show it on a number line, you may have seen this before, then we've got 1 going upwards, and this is x is greater than or equal to 1. We can also write x is that funny e or Greek e, which is a member of, and then we have brackets around 1 up to infinity. So those symbols, I have to look in the top right now. First of all, on the number line, the completed circle, as it were, filled in blob, means that that point is included, or that number is included. So that's why it's x is greater than or equal to 1. The arrow going up means it's going up to infinity. And then, as I mentioned, the Greek e means is a member of. And then for the brackets, we use a square bracket if the number next to it is included in the range of numbers that we're wanting to show, and we use a round bracket if it's not included, and of course that means that infinity or minus infinity always has a round bracket because we never get there. Okay, let's have a look at another one. So this time we have an open circle and it's going down to minus infinity, so we can say that x is less than 0, strictly less than 0. Meaning that 0 is not a possibility, not included. So that means that x is a member of the set from minus infinity up to 0, and notice we have a round bracket next to the 0 there to show that it's not included. And there's clarification of those symbols. So the open circle point is not included, and the arrow going to the left means down to minus infinity. Okay, here's another one. So we have an open circle at -3, a closed one at 2, and then a line in between. So this means that x is between -3 and 2, but our old symbols tell us that x is greater than -3, but less than or equal to 2. And we can show that with our brackets. So x is a member of round bracket -3, comma 2 square bracket, so meaning it's between -3 and 2. It could be 2 because that's a square bracket, but it can't be -3 because that's a round one. Now we've got 2 intervals on here, so it means that x is between -4 and -2, or between 2 and 4, and then you'd have to clarify which of the endpoints was included. We can write that as x is a member of the set -4 up to -2 union with the set from 2 to 4, and the union symbol means or. So this is saying x is either in the first interval or in the second interval. Okay, here's one where they overlap, and we need them to be in both of those. So the orange one tells us that x is between -3 and 1, including 1, and the red one says that x is between -1 and 3, including -1. And this is an AND situation, so we need values that are in both of these. What we use is the symbol, the upside down curve or quadratic type shape, or an N shape, and that is an intersection, and that means AND. So we're now saying that x is a member of from -3 up to 1 and from -1 up to 3, and so our conclusion is that x is a member of the set from -1 up to 1 with square brackets, meaning that either -1 or 1 are possible values, and so x is a member of that interval. Now, doing operations or actions on inequalities, we have to be careful. So we have rules. If a is greater than b, then we can say that a plus c is greater than b plus c, or a minus c is greater than b minus c. And that's for all values of c. An upside down a is a very useful symbol. It means for all. So turning that into easier language perhaps, adding to or subtracting from both sides of an inequality leaves the inequality unchanged. And we have some examples. So 7 is greater than minus 2. If we add 4 to both sides, then the inequality stays the same way around, and we end up with 11 is greater than 2, which we can see is true. 7 is greater than minus 2 again. This time we're subtracting 4 from both sides, and again it works out okay, and we end up with 3 is greater than minus 6, which again we know is true. Second rule, if a is greater than b and c is greater than 0, then ac is greater than bc, and a divided by c is greater than b divided by c. So what that means is that if we multiply or divide both sides by a positive number, this leaves the inequality unchanged. It's very important that positive there, because we'll see in a moment that if it's negative, that's not the case. So again, 7 is greater than minus 2. If we times both sides by 3, we end up with 21 is greater than minus 6, which is true. And if we divide by 3, we end up with 7/3 is greater than minus 2/3, which we can see is also true. Now, if on the other hand we have a greater than b and c is less than 0 or negative, then ac will be less than bc, and a over c will be less than b over c. So that means that if we times or divide by a negative number, we flip the inequality round. So multiplying or dividing both sides by a negative number reverses the inequality. So we've got 7 is greater than minus 2, and if we times by minus 3, at the same time as writing times minus 3, we turn the inequality round. And that's one of the main slips that people make, is forgetting to do that. So we end up with, in this case, minus 21 is less than 6, which is true. And with the division, we first write it with the inequality turned round, and then we cancel those minuses on the right hand side, and we end up with minus 7 over 3 is less than 2/3, which again is true. Now the final one comes in two parts. So if we know that two quantities multiplied are greater than 0, and remember we're dealing with numbers here for our examples, but these are rules that you can use in algebraic situations when you don't know what the numbers are. So we can solve problems in that way. So if AB is greater than 0, that tells us that either both A and B are greater than 0, or they're both less than 0. And if AB is less than 0, then that tells us that either A is greater than 0 and B is less than 0, or A is less than 0 and B is greater than 0. So to summarise, if a product, so AB is a product, if a product is greater than 0, then either both numbers are positive or both are negative. If it is less than 0, i.e. negative, then one of the values is positive and the other is negative. So, for example, we have 24 is greater than 0. We could split that into, say, 3 times 8, where they're both positive, or minus 3 times minus 8, in which case they'd both be negative. And then we can see that minus 24 being less than 0, then our example would have to be minus 3 times 8, so negative times positive, or 8 times minus 3, a positive times a negative. Okay, we've now looked at notation and operations, and we're now going to have a look at some actual linear inequalities. And essentially we solve these using the same techniques as for linear equations, but we've got to take care with multiplication or division by negatives, as we've just seen. So we'll have a look at some examples. So the first one has just one x, or one appearance of x. 4x minus 7 is less than 8, so we can add 7 to both sides, which gives us 4x is less than 15. We can then divide by 4, which gives us x is less than 15 over 4. No problems with that, it's all positive numbers that we were dealing with. And we have, using the other notation, x is a member of the interval from minus infinity up to 15 over 4, not including the 15 over 4. Okay, we now look at 7 minus 4x is less than or equal to 8. And there's two different ways we can look at this. The first one is just to go for it, so we take away 7 from both sides, leaving us minus 4x less than or equal to 1. And then we divide by minus 4, and we have to remember to reverse the inequality, so that will give us x is greater than or equal to minus 1 over 4. The other way we can do it is a sort of safety way, because you don't need to remember about the flipping it if you're dividing or timesing by a negative. So what we do is we move the 4x by adding 4x to both sides, so it becomes positive. So that leaves us with 7 is less than or equal to 8 plus 4x. We can then subtract 8, which gives us minus 1 is less than or equal to 4x. Divide by 4, minus 1 over 4 is less than or equal to x. And although we can read from that that x is therefore greater than or equal to minus 1 over 4, then if we were writing this in some sort of exam, we'd want to finish off by swapping the whole thing round, which gives us x is greater than or equal to minus a quarter. And as I say, that has the slight advantage of we don't have to worry about what happens if we times or divide by a negative, or even remember that. In interval notation, that would be x is a member of the set from minus a quarter up to infinity, and notice we have a square bracket with the minus a quarter because x could be equal to it, so it's included in the interval. Okay, moving on to examples with two x's. 3 plus 8x is greater than 5x plus 2. So first of all we'll subtract the 3 from both sides, giving us 8x is greater than 5x minus 1, and then we'll subtract 5x from both sides. So we have 3x is greater than minus 1, divide by 3 gives us x is greater than minus a third, and again no worries with the direction of the inequality there. In interval notation we have x is a member of the set from minus a third up to infinity, both round brackets, because minus a third is not included, not allowed, and of course infinity we never get there. Finally, for this page we've got 3 minus 8x is greater than or equal to 5x plus 2. So this is another one where we've got alternative ways of doing it. First of all, we'll go for the straightforward, so we subtract 3 from both sides, so we have minus 8x is greater than or equal to 5x minus 1. We then take away 5x, so we have minus 13x is greater than or equal to minus 1, and then we divide by minus 13, which means we have to swap the inequality around because we're divided by a negative. So that gives us x is less than or equal to 1 over 13. Alternatively, we could subtract 2 to start with, so we have 1 minus 8x is greater than or equal to 5x. We could then add the 8x, so we have 1 is greater than or equal to 13x. Then divide by 13, 1 over 13 is greater than or equal to x. Again, flip it around, and that's the whole thing, so that tells us that x is less than or equal to 1 over 13. And that's the slightly safer way of doing it. So x is a member of the set from minus infinity up to 1 over 13, with a square bracket for the 1 over 13 because that is allowed. Okay, moving on to modelling, and I've called them little stories as a slightly jokey comment, but anyway, little stories that can include inequalities can be tricky. So we'll have a look at an example. Adrian is more than 1/3 his mother's age, and the sum of their ages is less than 100. Adrian was born on his mother's 32nd birthday. By expressing these facts as two inequalities and one equation, find the range of possible ages for Adrian. Now notice that they don't have to write that first sentence. They might just put find the range of possible ages for Adrian. and then you've got to think of using inequalities. But given that it says more than and less than, one would hope that that would pop into your mind. Okay, so what do we have? Well, first of all, we're going to let Adrian's age be x and his mother's y. Nice familiar letters. And then we can sort our inequalities out. So Adrian is more than 1/3 his mother's age, and that means that x is greater than, more than, y over 3. So Adrian's age x is greater than his mother's age y divided by 3. Then we have the fact that the sum of their ages is less than 100, so that's going to be x plus y is less than 100. And we also know that Adrian was born on his mother's 32nd birthday, so that isn't a more than or less than, that is actually a fact or an equation, so we have x plus 32 equals y. So how to proceed? Well, what we can do is we can use equation 3 and put them into the inequalities and therefore get rid of y from the inequalities. That means we'll only have x's and we can find out the ranges of values, or the range of values rather, for x. So if we put equation 3 into equation 1, then x is greater than y over 3 becomes x is greater than x plus 32 over 3. If we put equation 3 into equation 2, then we have, instead of x plus y is less than 100, we have x plus 32 is less than 100. Okay, we now need to sort those equations out. So the first one we're going to times by 3, which gives us 3x is greater than x plus 32. We're then going to take x away from both sides, so that gives us 2x is greater than 32. And then we're going to divide by 2. So we have x is greater than 16. For the other one, first of all we put those x plus x together to make 2x. Then we're going to subtract 32. 2x is less than 68. And then we're going to divide by 2. So x is less than 34. So we can see we've got our answer now. What we can say is that x lies between 16 and 34. And then we put it into words. So Adrian is aged between 16 and 34. Now, graphically, the way that we draw these is, for x is greater than y over 3, we've drawn x equals y over 3, and we've given it a dotted line because it's a strict greater than. For x plus y is less than 100, we've drawn x plus y equals 100, and a dotted line because it's strictly less than. For x plus 32 equals y, we've drawn a line, and that's a solid line because the points must lie on it. In fact, when I say must lie on it, if that were an inequality, we would use a solid line if the boundary is included, so if it's a less than or equal to or greater than or equal to. The next thing we would do if we were solving it graphically is we would shade the bits we want, or we'd shade the bits we don't want. As long as you're clear on what you're doing, it doesn't matter. So for the first one, x being greater than y over 3 means we need to be to the right of that line, as it were. So we'd shade that side in. And for the next one, x plus y being less than 100, we need to be on the left-hand side of that line. So that would be there. And then the possible ages are where those coincide, and so we can see that between those two black points, and they are in fact the values 16 and 34 for x, and so that confirms the algebraic answer we got. And just to remind you, graphically, for strict inequalities we use dashed lines, and for non-strict we use solid lines.